Hello everyone, welcome back to my YouTube channel. My name is Lakshmi, a student of Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering Data Science. In this video, we'll be learning about the subject Mathematics for CSE stream. Now let's move on to the contents of the video. The contents are vector and scalar, dot product and cross product of two vectors, angle between the two vectors, divergence and curl of a vector, application of vector calculus. Now firstly is vector and a scalar. Vector, a physical quantity which has both magnitude and direction. Example is velocity, acceleration, force. Scalar, a physical quantity which has only magnitude, no direction. Example is weight, length. The dot product and cross product of two vectors, it is being represented as follows. Consider two vectors, that is a and b. Dot product of two vectors, it is denoted by a dot b is equal to magnitude of a magnitude of b cos theta. The cross product of two vectors is being denoted as a cross b is equal to magnitude of a magnitude of b sin theta n cap. The angle between two vectors, we know that a dot b is equal to magnitude of a magnitude of b cos theta. If we want cos theta, that is angle, we should shift it to the LHS. We'll be getting as a dot b divided by magnitude of a magnitude of b. This is the formula for the angle between two vectors. The dot product and cross product, here is a small example for the dot product of a vector, that is vector a is being given with a vector, that is ax I cap plus ay j cap plus az k cap, and it is being multiplied with the vector b, that is bx I cap plus by j cap plus bz k cap. We'll be getting the dot product as ax bx plus ay by plus aj az bz. That is the vectors I, j, k vanishes in the content, that is I dot I, j dot j, k dot k is equal to 1. That is nothing but the dot product of like vectors will be getting 1, and the dot product of unlike vectors like I dot j, j dot k and k dot I will be getting as 0. The unit vector. Consider a unit vector A. It is being denoted as A cap, and it is given by A cap is equal to A divided by magnitude of A. The scale field. In each point x, y, z, there exists a scale function, that is say as a phi. Then it is being represented as x square plus y square plus z square minus r square. It is an example for the scale field. Now let's move on to the vector field. In each point x, y, z, there exists a vector function, say vector whose components are real valued function called as a vector field. Example is a is equal to ai cap plus bj cap plus c k cap. Gradient of a scalar, that is if phi of xyz is a continuous differential function, then the gradient of phi of grad phi is denoted by grad phi. Then it is nothing but the partial differentiation with respect to y, x and z. F of x, y, z is nothing but a x square y plus z. If we do the gradient for this, that is nothing but the function f should be differentiated partially with respect to x, with respect to y and with respect to z as well. F of x, y, z will be getting as x square y plus z. We should, if we differentiate that with a partial, will be getting as 2xy I cap plus x square j cap plus k cap. This is the answer for the grad phi for this problem. And if we find the angle between for these two vectors, that is I cap plus 2j cap minus k cap, and the other vector, that is minus I cap plus j cap minus 2k cap, we'll be getting the answer in the form of a dot b is equal to a magnitude of b cos theta. If we solve it for the cos theta, we'll be getting as a dot b divided by magnitude of a magnitude of b. Now we should multiply the two vectors with respect to the dot product. We'll be getting an answer if we substitute all the above things in the formula, that is cos theta is equal to a dot b by magnitude of ab. We'll be getting an answer as 1 by 2. For theta, the cos inverse 1 by 2 will be equal to 60 degree. Divergence and curl of a vector. Divergence is nothing but the formula will be denoted as f is equal to f1 I plus f2 j plus f3 k. If the grad will be equal to partial differentiation where the I, j, k vectors vanishes, but the curl of a vector, that is dou cross f, that is equal to the determinant of ijk, that is partial differentiation with respect to f1 f2 f3 where the ijk terms exist, but in the dive the ijk terms will be vanishing. The problem will be solving on the dive f is nothing but a f is equal to grad of x cube plus y cube plus z cube minus 3xy. If we partially differentiate the above function with respect to x, we'll be getting a value plus partially differentiation with respect to y plus partial differentiation with respect to z. We'll be getting the value, but in the final answer, the terms of I, j, k will be vanishing. So we'll be getting the answer as, that is 3x square minus 3yz, 3y square minus 3xz plus 3z square minus 3xy. It is the answer where I, j, k terms vanishes. The curl of a vector, that is grad of f is equal to partial differentiation I partial differentiation y plus partial differentiation z. If the function, that is the equation is 2xy plus 2y I cap plus x square plus 2x j cap plus 2z k cap. The curl grad phi grad f, that is nothing but the determinant of I, j, k, that is partial differentiation with respect to x, y, z we will be doing, and so that we will be getting the answer there where x, y and z and I cap, j cap, k cap will be existing in the answer. Curl of a vector, that is nothing but will be having here the divergent as well as curl of a vector in the same problem. Vector f is given, the question has been given. If we do the divergent of a vector where I, j, k terms will be vanishing, so the answer will be 6x plus 6y plus 6z. If we do the curl for the same problem, we'll be getting the answer in the terms of x, y, z as follows. It is being shown in the picture. Now let's move on to the applications of vector calculus. Physics. Vector calculus is extensively used in the physics to describe and analyze the behavior of a physical system. Engineering. Engineers use vector calculus to model and analyze the system in the fields such as structural engineering, control theory, signal processing, and robotics. Computer graphics. Vector calculus play a key role in computer graphics for rendering images, stimulating physical phenomena like light transport, and modeling complex shapes and surfaces. Aerospace. In aerospace engineering, vector calculus is used to analyze fluid flow around aircraft, spacecraft trajectories, and control systems. That is all about my presentation. Thank you for watching. Please do like the